Okay, hello. Can you see my screen? If anybody can answer.
Yes, ma'am.
So we were solving questions on Malus law. So this is a question from JAM 2007. Okay, so we'll attempt to solve this. So I will maximize the screen so that you can see the options.
हम ऑप्शंस को आप राइट साइड में कर लो ना तो आ जाएंगे वैसे ऐसे भी ठीक है
दिख जाएंगे ठीक है So the question says that we have three polarizers P, Q, and R, which are placed parallel to each other with their planes perpendicular to the z-axis. So first, try to draw whatever configuration is given to you. Okay, and Q is placed between P and R. Initially, the polarizing directions of P and Q are parallel. That means the transmission axis of P and Q are parallel, but that of R is perpendicular to them. That means R kisme crossed position pe. In this arrangement, when unpolarized light of intensity I naught is incident on P, then the intensity coming out of R is equal to 0. So ये तो हमें समझ आ रहा है that why this is happening. So if I say that this is my polarizer P and this is my polarizer Q and this is my polarizer R, but R ka pass axis kya hai? It is perpendicular. So let us say it is this. So I'm getting zero intensity. So starting May, I naught intensity is incident and these are transmission axes. ये जो मैंने solid black line draw करा है, that represents the transmission axes. So the axes of P and Q are parallel, but R is perpendicular to them. Now the polarizer Q is rotated. So now what is being done is this, the pass axis I am rotating like this. Okay, I'm rotating it. And as a function of the angle of rotation, no, I'm actually rotating it with respect to Z. So Z axis यहाँ पे बनाना पड़ेगा पहले. Okay, so the question says that are parallel with their planes perpendicular to Z. That means this is my Z axis. And now what I'm doing is the polarizer Q is now rotated about the Z axis. So that simply means that this angle I am measuring with respect to my Z, this theta. And I'm rotating it about I'm basically rotating this polarizer about the Z axis. So the pass axis I'm rotating. So पहले pass axis ऐसे था, this was my Z axis. Now I am rotating it like this. Okay. So ये figure में सही से समझ नहीं आ रहा, but can you visualize it? First it was like this and Z axis is going like this. Now I'm rotating it like this about the Z axis. So Z axis के through I'm rotating my polarizer. So the pass axis is getting rotated like this. जो x y plane है उसमें pass axis rotate हो जाएगा. ठीक है. So अब what we have to do is we have to tell that out of these four options, okay, what is the output of the light. जो intensity आ रहा है मुझे बाद में मिल रहा है वो intensity क्या है. That is what you have to find out. me see what is my answer. Okay, Sanchit, your answer is not correct. Okay. Rajat, your answer is correct. And Mansi, your answer is not correct. Dhruv, your answer is correct. No, Sanchit, it's not correct now also.
Okay, I've got it.
Diptanshu, your answer is not correct. Mansi, it's not correct again. Sanchit, now it's correct. Okay, so let us see what we are doing. So first, what is being told to me is that I have an unpolarized light. So here, the incident light is unpolarized. Mansi, your answer is still not correct. It's okay. Let us see, okay? So I have an unpolarized light. So I know that simply after passing through the polarizer P, I should get a plane polarized light like this and of intensity I0 by 2. This I know. Now I have rotated the axis of Q. So Q का axis अब ये है. ठीक है? So this is the axis of rotated pass axis of rotated Q. Okay, so it is making an angle of theta with respect to the z axis. That means that it is making, और ये जो मेरे पास input light है, which is like this, right? So this, I have to take the component of the beam shown in green along this orange line, where is the pass axis. So this angle is now 90 minus theta. So what will I get out of this? I will get a light polarized parallel to the pass axis, and the intensity would be I0 by 2 multiplied by cos square 90 minus theta, right? And now this is now incident on my polarizer R, but अब जो ये R है, it is along the x axis. Okay, so हमारा coordinate system क्या है? This is y, this is x, and this is z. So now this is parallel to the x axis, and इसके ऊपर this light is incident like this, right? So this angle क्या था? This angle will become theta here, and I'll get a light which is now like this, and I will get I0 by 2 cos square 90 minus theta and cos square theta. So this will become I0 by 2 cos square theta sine square theta. So I want to convert this into, it is right. So I final क्या मिल रहा है? I final is equal to I naught by 2, and I want to write it as sine 2 theta square. Okay, that means I have to divide it by 4. So I will get I naught by 8 sine 2 theta square. Okay, so this is the final I that I'm getting. And because I'm doing sine square, so I know that कुछ मतलब साइनोसॉइडल ग्राफ मुझे मिलेगा. I can think of that कि कुछ मुझे इस तरह का ग्राफ मिलेगा जिसमें ये जो मैक्सिमम इंटेंसिटी है वो I naught by 8 होगी. But I need to find out that where will I get maximum here, okay? At which point I'll get maximum and at which point I will get minimum. So I need to, then I know that sine theta is maximum when this is equal to 90 degree. So that means theta should be 90 by 2 or 45 degree. Only then I'll get the maximum intensity. So this should be 45 degree. And when 2 theta is equal to 180 or 2 theta is equal to 90 degree, I should get minimum. Matlab my I final is equal to 0 when this is satisfied, and I final is equal to I naught by 8 when this is satisfied. Okay, so this should be 90 degree or pi by 2. This is pi by 2. This is pi by 4. So then I'll go back and check where this is satisfied. So this is satisfied in option number B, jahan par this is pi by 2 and this is happening at pi by 4. Okay. So now if I look at option number D and option number B, so they are similar, but only the values given on the x-axis are different. So that is something you have to pay a little bit of attention to. Okay. Otherwise, you'll tick the wrong answer. And you will also get the wrong answer if you see option A and B. Okay, वहाँ पे x-axis नहीं, वहाँ पे भी गलत है. If I see option C and B actually, वहाँ पे x-axis same है, but वहाँ पे क्या difference है? वहाँ पर ये I naught by 2 का factor missing है. वहाँ पे the student has forgotten that the input is an unpolarized light. So now that is the trick in this question. Okay, so options are given like that या तो we'll forget to check what is on the x-axis, or we will forget to check what is on the y-axis, or we will forget to put this factor of 2. Okay, so सब कुछ सही करूंगी and I will get the option C because I've forgotten this factor of 2. इसलिए I've been saying this again and again that always check in the question that what is the input light. यहाँ पर लिखा है question में that the input light is an unpolarized light. Okay, so we have to remember that what is the input. So let us try another question. So this is a question from JAM 2011. So here, what is given to you is that 3 graphs are given. Okay, so intensity of 3 different light beams after passing through an analyzer is found to vary as shown in the following graphs. So agar analyzer mila hai, so basically what we are checking, we are sort of making a graph. हम analyzer का pass axis rotate कर रहे हैं and उसके corresponding हर एक theta value पर क्या intensity का value आ रहा है, that I'm plotting. Okay, so these are the curves which I've obtained by varying the pass axis का angle जो है, which it's making with, let us say, with the y axis. I'm rotating and I'm measuring, I'm noting down कि क्या intensity variation हो रहा है. So I'm getting these 3 different type of graphs corresponding to 3 different types of input beams. So we have to identify that out of the options, ये ग्राफ जो है वो कौन कौन सी टाइप की लाइट को रिप्रेजेंट करता है. ठीक है, so that is the question. So give it some thought. So the option, let me check which option is correct. Sanchit, your answer is not correct. Rajat, your answer is correct. Dhruv, your answer is correct. Actually, इस क्वेश्चन में अगर एक भी कोई ग्राफ फिगर आउट कर लेंगे ना, आई थिंक यू विल गेट द आंसर. The options are not made that difficult. ठीक है, just think about it, give it a little bit of time. So यहाँ पर जो input है in graphs का, that can be a light in any of the polarization states. So it can be a unpolarized light, it can be a light in P state, or a RCP, LCP light, or an elliptically polarized light. So before, you have to give it some thought that what will happen अगर मेरे पास ये different तरह का light आएगा. ठीक है, so just think about it. Mansi, your answer is not correct. Also, when you are, even making an intelligent guess, so at least check that for the rest of the graphs, is your option making any sense? The option that you are choosing. Okay, so देखते हैं इसको थोड़ा सा ध्यान से. So let us look at graph number 1. Okay, so here what is it showing? That I have the analyzer and I'm rotating the analyzer and there is no change happening in the intensity. So if I look at graph A, so this is A, let us say. So there is no change in intensity as I am rotating my analyzer. So no change in intensity, right? With theta. So what is theta? Theta is the angle by which I'm rotating my analyzer. So when can this happen? So then this can happen when I have an unpolarized light, because we know कि अगर unpolarized light होता है, so what do we get? We get, अगर I naught intensity का है, so I'll simply get I naught by 2, and there is no dependence on theta in this case. Okay? But now this is also true. Okay, so this is also true for one more type of light. And what is that? That is circular polarization. Okay, ये क्यों correct है? We'll have to give it some thought. So circular polarization में क्या होता है? That I have E naught cos kz minus omega t I cap plus E naught sin kz minus omega t j cap. Okay, so इस तरह से I can write some electric field for a circularly polarized light. So now what is going to happen is, see, because the magnitude, this E naught का जो magnitude है, वो दोनों components में same है. Both components have same amplitude. So अगर if I will try, अगर मैं इसके ऊपर अब Malus law लगाऊंगी, you can try to check it yourself. So what is going to happen? Let us consider two only simple cases. Let us consider the case in which जो analyzer है, it is directly parallel to my I cap, and therefore जो J cap है वो completely block हो गया. तो total intensity क्या था? Total intensity was twice of E naught square. But if I consider the case that analyzer is directly parallel to the I cap and only, the J cap is completely blocked, तो ये intensity की जगह मुझे E naught square मिल गया सिर्फ, because one half got completely absorbed. If I consider another case in which the analyzer का pass axis is parallel to the J cap, तो तब क्या होगा? X component completely blocked हो गया, only the jth component passed, and the jth component is now again equal to E naught square. ठीक है? Now let us consider a third case. तो अगर मैं कोई third case consider करूं जिसमें जो analyzer है उसका pass axis let us say कुछ 45 degree angle बना रहा है मैं, we can check it for all theta, but I am just roughly, discussing three simple examples so that we can understand this graph is also true for circular polarization. So अगर मैं 45 degree angle लूँ, तो if I will take the first component, तो first component क्या हो जाएगा, E0 by √2 हो जाएगा, √2 भी नहीं, E0 by cos of 45 square हो जाएगा ना. That is going to be the Malus law. I'm applying Malus law on the ith component. So that will give me this. And if I will apply Malus law on the second component, so that will also give me cos 45 square. So this is E0 by 2 and this is E0 by 2. Again, when I'll add them, I'll get E0 square plus E0 square and I'll get, what will I get? By 4 aa jayega. So that is twice. ये half तो नहीं होना चाहिए था. एक सेकेंड, कुछ गलती कर दिया. ठीक है, कुछ गलती कर दिया मैंने. वेट अ सेकेंड. ये E0 स्क्वायर था ऑलरेडी. यस, सो इंटेंसिटी इज सिंपली दिस ना. हाँ, मैंने स्क्वायर क्यों किया? इंटेंसिटी आता है ना मैलिस लॉ से. सो द इंटेंसिटी ऑफ x इज इक्वल टू दिस, इंटेंसिटी ड्यू टू y इज इक्वल टू दिस. सो दैट इज E0 स्क्वायर बाय 2 plus E0 square by 2, that is 2 times E0 square by 2, that is just E0 square. Now it's correct. Are you understanding what I'm saying, or is it not making sense to you? So what I'm talking about is कि अगर मैं circular polarization लेती हूँ and I consider the case that my analyzer is making a angle of 45 degree with respect to my X and Y directions. Is it making sense to you, or do you want me to explain it again? What I'm saying?
बहुत ज़्यादा तो नहीं आया समझ में.
ठीक है, तो let me explain this to you because ये slightly important ही है. Let me write it again. I thought कि it will be. Let us do it again. So first case तो हमें समझ आ गया कि unpolarized होना चाहिए, उसमें तो कोई मतलब डाउट नहीं है हमें. ठीक है. सेकेंड केस जो हमें स्टडी, जो मैं बोल रही हूँ होना चाहिए, दैट इज फॉर सर्कुलर पोलराइजेशन. So let me take that I have some electric field for a circularly polarized light. So ये हम पढ़ चुके हैं. हम उसको लिख सकते हैं cos kz minus omega t I cap plus E0 kz minus omega t j cap. फिलहाल we are not interested in the fact that is it RCP or LCP. We are only interested in one circularly polarized beam. So how do I know it is circularly polarized? There were two things. एक तो था कि दोनों components का amplitude same होना चाहिए, which is E0. X component का amplitude भी E0 है यहाँ पे, Y component का amplitude भी E0 है. And the second thing that I have to check is there should be a phase difference of phi between the two components. So one is a cosine function, other is a sine function. So that means it is a circularly polarized light. This we have discussed in detail a class pehle. Okay? So this is a circularly polarized light. Now I am saying that if I will take this circularly polarized light and I will pass it through an analyzer, and I will vary the pass axis of the analyzer. So I should get a graph as shown in figure A. Okay, this is what we are trying to do. So now let me consider three cases and try to explain this. Let me consider case number A, जिसमें this electric field.
Ma'am, one doubt, ma'am. Ma'am, for circular polarization, ma'am, the phase difference must be 90 degree or any constant phase difference works?
No, not constant phase difference. It can be a multiple of 90, but it has to be 90.
Oh, yeah.
It can be pi by 2 plus something, but it has to be like a cosine and sine. Only then you can make a circle.
Yes, ma'am.
You want to make a circle, right?
Hmm.
So, okay, so let us consider the first case. So what I'm saying is, let me draw my analyzer. So ये मेरा कोई analyzer है, and I am choosing that this is the pass axis of the analyzer, and this is my x-axis, this is my y-axis. So इसके about I cap है, इसके about j cap direction है. Okay? So now the pass axis of my analyzer, I am saying that analyzer का जो pass axis है, it is parallel to j cap. Okay, that is the first case. So now what will happen? Incident electric field kya hai? It is given in equation 1. Okay, so this incident electric field falls onto my analyzer, and what will I get? I will get output mein, what will I get? I will get that E is now equal to E naught sine kz minus omega t j cap. Correct? Because I cap component will get completely blocked. Only the component which is parallel to my analyzer pass axis will be passed. ठीक है? So अब मेरे पास input intensity क्या था? So input intensity was, अगर मैं उसको I naught लिखूं, so I naught was equal to E naught square, the intensity of the X component, plus E naught square, the intensity of the Y component. So input intensity was equal to this. ठीक है? अब मुझे output intensity क्या मिला? Output intensity is that I naught, not I naught, इसको I लिख लेते हैं, that I is now equal to what? This is my output, E output, this is my E input. Okay. So output intensity मुझे मिली that it's equal to E naught square. So I have reduced the intensity to half. So it is similar in a way, lag raha hai ki this case is similar to an unpolarized case, which makes sense because analyzer is completely blocking one component of the light. Okay. Similarly, I can do a second case. I can do case number B where I have analyzer jiska pass axis is now parallel to X cap or I cap. Direction is denoted by I cap. Okay. So now I have my analyzer, but the pass axis of this analyzer is oriented parallel to the x-axis. So I can do the same analysis and I will get that the output field E output in that case is going to be E naught cosine kz minus omega t I cap. Complete j cap वाला जो component है y एक्सिस के अलोंग जो भी पोलराइज्ड बीम का कंपोनेंट है वो सब का सब एब्जॉर्ब हो गया एंड ओनली द कंपोनेंट पैरेलल टू द आई एक्सिस वाज अलाउड टू पास. सो देन माय आउटपुट इंटेंसिटी इन दिस केस इज आल्सो इक्वल टू ई नॉट स्क्वायर. ठीक है. Now these two cases were very trivial, just same like a unpolarized light that I'm blocking one component and letting the other component pass. But notice this will not be true if it is an elliptically polarized light. Elliptically polarized light के भी दो component होते हैं, एक को मैं block कर सकती हूँ, एक को मैं pass कर सकती हूँ. But उसमें क्या होगा? Both components do not have the same magnitude. एक कुछ EX magnitude होगा, एक कुछ EY magnitude होगा. Circularly polarized light का first condition होता है that the magnitude or the amplitude of both ith and jth components are equal. Therefore, irrespective of the fact ki which component I am blocking and which I am passing, each time I am getting same output intensity, which will not be true for an elliptical polarization. Because in elliptical, यहाँ पर मुझे क्या मिल जाएगा? EY मिल जाएगा कुछ EY square, and for the second case, I'll get some EX square, and EX and EY amplitudes are different. So that means my graph cannot be a straight line in that case. उसमें कुछ तो variation आएगा. ठीक है. So now let us do a third case that I want to keep analyzer जिसका pass axis at 45 degree. We can also check it for 60, 30 and any other theta that you can try as in homework. I'm doing the simplest example as a demonstration. So let us say this is my analyzer. So now what I'm saying is that the pass axis is at 45 degree. So now this is my Y and this is I cap direction, this is J cap direction, and this angle is 45 degree. So this is the third case that I am considering. ठीक है. So अब क्या होगा, मेरा इलेक्ट्रिक फील्ड जो है उसका x कंपोनेंट क्या होगा, इलेक्ट्रिक फील्ड का x कंपोनेंट था E नॉट. ठीक है, इंटेंसिटी लिखते हैं सीधा क्योंकि हमने मैलिस लॉ हमें अप्लाई करना है. सो लेट अस अप्लाई मैलिस लॉ. ठीक है, सो लेट अस लुक एट द ith कंपोनेंट. सो ith कंपोनेंट क्या हो जाएगा, पहले ith कंपोनेंट का इंटेंसिटी क्या था, E नॉट ही था. ये cos kz minus omega t is just telling you that there is a sinusoidal variation. उसको हम नहीं कर रहे, एम्पलीट्यूड का स्क्वायर कर रहे हैं ना इंटेंसिटी के लिए. सो एम्पलीट्यूड इज ई नॉट. सो मेरे पास पहले इंटेंसिटी था ई नॉट स्क्वायर. ठीक है, बट नाउ आई हैव टू अप्लाई मैलिस लॉ. एंड व्हाट इज दैट मैलिस लॉ, व्हाट इज द एंगल, जो ith कंपोनेंट है वो पास एक्सिस के साथ 45 डिग्री एंगल बना रहा है. सो आई विल टेक द कंपोनेंट ऑफ द x ऑफ, जो x कंपोनेंट है इलेक्ट्रिक फील्ड का, उसका मैं कंपोनेंट लूंगी अलोंग द पास एक्सिस. सो आई विल गेट cos स्क्वायर 45 डिग्री. ठीक है, विच इज इक्वल टू, दिस इज इंटेंसिटी अलोंग x. सो दिस इज नाउ E नॉट स्क्वायर and cos of 45 is 1 by root 2. So I will get a half because this is cos square 45. So now this much intensity is going to pass. अब देखो इसमें से पास होने के बाद मुझे क्या मिलेगा, I will get a line light which is going to be polarized like this. ठीक है, पर ये ऐसा polarized light कैसे मिलेगा, I will get some component of the light which जो x component था उसका मैंने कुछ component लिया along the pass axis, जो y के along component था इलेक्ट्रिक फील्ड का उसका भी एक component लिया along the pass axis, and उसके उन दोनों को ऐड करके मुझे फाइनल लाइट मिलेगा, राइट. सो नाउ दिस इज माय इंटेंसिटी ऑफ द, this intensity component is coming from the ith component of the beam. Similarly मेरे पास jth component है. So intensity due to IY, मतलब ith component की वजह से क्या इंटेंसिटी मुझे मिल रही है. So I will again get E naught square, and again जो jth component है उसका मुझे मतलब component लेना है along the pass axis. So again this angle is also 45. So I will again get cos square 45. So this is going to be E naught square by 2 again. And total intensity क्या होगी, I is going to be equal to the Ix plus Iy. ठीक है, so that is E naught square by 2 plus E naught square by 2, that is also equal to E naught square. So by taking 3 different values of analyzer का pass axis का 3 different positions हमने consider किया, when it's at 45 or when it's parallel to I or when it's parallel to J, and तीनों cases में we saw that output intensity comes out to be E naught square, which is half of the input intensity. We can also check it for any other angle, matlab we can also check it for 60, 30 like that. So you can try that at home and you will check that each time you will get E naught square as the output intensity. So that means कि मेरा जो ये curve आ रहा है shown in graph number 1, that is also true for a circularly polarized light. तो अगर मैं circularly polarized light लूंगी, circularly polarized light को भी हम एक unpolarized light की तरह visualize कर सकते हैं. It is up to us that what x and y axes we want to choose for a circularly polarized light. हम उसको भी अलग axis में decompose कर सकते हैं. The x and y axes are not fixed. It's for us to choose ki which 2 components we want to choose. But this graph is only true for a circularly polarized light, because in a circularly polarized light, both the x component and y component have the same amplitude. This graph is not going to be true for an elliptically polarized light, क्योंकि elliptically polarized light में जो हमें मिलता है वो इलिप्स मिलता है ना। तो इलिप्स में जैसे जैसे मैं एंगल चेंज करूंगी, द ओरिएंटेशन में कितना कंट्रीब्यूशन आ रहा है EX और EY का, दैट इज गोइंग टू स्लाइटली वेरी. It's going to give us something which is shown in graph number C. So if I say this is C and if I say this is B, so an elliptically polarized light will have some kind of a small variation because it's like an ellipse. So one component is bigger than the other component. So when I will slightly analyze the light in the same way, जैसे अभी हमने circularly को analyze करा है, so I'll find that the component will slightly go through a maxima and minima. एक जो ellipse होता है, ellipse ऐसे होता है ना, so it's going to have some major axes and some minor axes. तो जब भी मेरा एनालाइजर का पास एक्सिस मेजर एक्सिस के अबाउट मेजर एक्सिस के पैरेलल होगा तो आई विल गेट मैक्सिमम इंटेंसिटी. एंड जब भी मेरा एनालाइजर का पास एक्सिस माइनर एक्सिस के पैरेलल होगा, आई विल गेट मिनिमम इंटेंसिटी. So an elliptically polarized light would actually go through a little bit of maxima and minima, not too sharp, but some kind of a variation is going to happen. Okay, so let us write that down. So अगर मैं ग्राफ C का बात करूं तो this will actually correspond to an elliptical polarization. So why? Because first thing is कि elliptical polarization का अगर मैं electric field लिखूं, I will have some EX sine of kz minus omega t I cap. Actually हमने ऐसे लिखा नहीं है उसका, EY कोसाइन या दोनों को ही कोसाइन करके एक फाई ऐड कर देते हैं, कोसाइन kz plus omega t plus epsilon. Okay, so this epsilon is the phase difference which can take any value. So we have not specified. And here EX amplitude is not equal to EY amplitude. So we know that it's an elliptical polarization. And I'm going to get something like this. So if this is my x-axis, this is my y-axis, and this is my major axis, this is my minor axis. So I can make a mental note that when analyzer parallel to major axis, I output is going to take its maximum value. वो क्या value होगी, that will depend on the exact form of the electric field that we are considering. But in general, that is going to happen. And when analyzer parallel to minor axis, my I output is going to be minimum. Okay. You can also think of it in this way. When your electric field is pointed like this, okay, this is your E field. So when your electric field is pointed parallel to the major axis and the pass axis of the analyzer is also parallel to the major axis, this electric field will simply pass. पर जब electric field major axis के along pointed होता है तो उसका magnitude बड़ा होता है. Instead, अगर मैं ये electric field consider करूं, so the magnitude of this vector, this E vector is smaller than the magnitude of the vector which is pointing along the major axis. So therefore, I will get a small minima and maxima. Okay. So this graph number C actually corresponds to an elliptical polarization. It is not a complete जो intensity है. देखो why am I saying that it's for elliptical? ठीक है. Because if I see कि ये जो minima जा रहा है, what is this value? This value, and if I consider this value. So this, ये जो इसका null, ये जो इसका minimum position है यहाँ पर, it is not equal to 0. That means कि some light is passing. I have not completely blocked all the light. अगर मैं completely एक component block कर दूंगी, that means I have a p polarized light. So graph B जो है, it is corresponding to a linear polarization. अब उसको भी हम इस सेम तरीके से ही समझेंगे, ठीक है। पर पहले चलो ग्राफ बी देख लेते हैं. मतलब I am spending so much time on this because this is a fundamental concept and any type of question on this kind of concept should be clear to you, okay. कि analyzer से how can we interpret the output. So graph number B जो है it will correspond to a linear polarization. Let us see how. So if I have some electric field, so I can write, I have some EX I cap and EY J cap. So currently I'm not including the sine cosine variation with this. Let us consider कि एक कोई linear polarization है जिसका कुछ एक EX EY के term में I have decomposed. So अब क्या होगा? If my analyzer is parallel to the ith component, तो jth completely block हो गया, तो intensity क्या हो गई? इंटेंसिटी EX स्क्वायर हो गई, ठीक है. अगर माई एनालाइजर इज नाउ पैरेलल टू द jth component, that means the ith component completely got absorbed and only the EY component was passed, ठीक है. तो like that I can choose that which component is passing. But now if my linear polarization has only one component which is EXI, अब क्या होगा? अगर मेरा एनालाइजर आई के पैरेलल है तो कुछ पास हो रहा है, बट अगर मेरा एनालाइजर आई के पैरेलल नहीं है बल्कि जे के पैरेलल है तो कंप्लीटली आई एब्जॉर्ब हो जाएगा और मुझे इंटेंसिटी 0 मिल जाएगा. आर यू अंडरस्टैंडिंग? सो दिस कर्व, if I look at graph number B and I look at the magnitude of intensity, that how it is changing. So it is changing. Maxima पे it's 1, मतलब the whole intensity is passing, but at minima it is equal to 0. So what this tells me is that it can correspond to a linear polarization in which my electric field is either parallel to I or either parallel to J, or if it has two components, अगर उसके इस तरह के भी दो components हैं, EX and EYJ भी हैं, तो let us draw this. Let us say then this is my electric field E, ठीक है, corresponding to this. So now I can orient my analyzer in this direction, that is at a perpendicular angle. So this can be the analyzer का pass axis. So that I output is equal to 0. Is that okay? So if I take any type of plane polarized light, चाहे वो X के पैरेलल हो, चाहे Y के पैरेलल हो, या फिर इलेक्ट्रिक फील्ड का कोई भी ओरिएंटेशन हो XY प्लेन में, I can always find out one orientation of the analyzer so that it's making an angle of 90 degree with respect to this electric field, and the output will be completely equal to 0. So for a linearly polarized light, अगर मैं एनालाइजर का theta change करती रहूंगी, so I will go through this complete cycle that I'll get maximum intensity, then I will slowly go to 0 intensity, then slowly intensity will increase and go to maximum. So I will go through this whole cycle. So graph B corresponds to a linear polarization, and graph C also looks like a linear polarization, but it is not a linear polarization because जो टोटल वेरिएशन हो रहा है ग्राफ में, इट इज नॉट गोइंग टू 0. ये जो मिनिमम वैल्यू है, ये जो यहाँ पर जो मुझे आई मिनिमम मिल रहा है, दिस इज नॉट इक्वल टू 0. सो व्हाट दैट टेल्स मी दैट आई एम नॉट completely getting rid of all the light. Some light is always passing. So then ये कौन सा केस हो सकता है? ये एक इलिप्टिकल पोलराइजेशन का केस हो सकता है जिसमें यहाँ पर my analyzer is parallel to the minor axis of the ellipse. So that is why I am getting slightly reduced intensity, but I am getting some intensity which is not equal to 0. Okay. So if I look at the options now, so I know graph B is a linear, graph C is an elliptical. Okay. And graph A can be either unpolarized or circularly polarized. So that if I look at the option, only option number B जो है is satisfying all the three graphs. अब इसमें क्या था, अगर मुझे मान लो बाकी कुछ भी नहीं आता था, इसके ऑप्शंस ऐसे दिए हुए थे कि अगर मैं ग्राफ बी को भी इंटरप्रेट कर लूँ दैट इट कॉरेस्पॉन्ड्स टू लीनियर पोलराइजेशन, जो कि काफी ऑब्वियस भी होना चाहिए, तब भी आई कुड हैव फिगर्ड आउट द राइट आंसर. बट वेयर डिड यू गेट स्टक? You get stuck कि I will just match graph A and that will give me the answer. But actually graph A 3 options के लिए correct था. ठीक है. So मतलब ऑप्शंस इस तरह से दिए थे इसमें कि ग्राफ बी भी अगर जो सबसे सिंपलेस्ट केस है अगर वो भी कर लेते तो आंसर्स यू वुड हैव गॉटन द करेक्ट आंसर. But I wanted to do this question in detail so that any other question of analyzing a graph comes about. So you should have a little bit of understanding that how to think about a graph. Elliptical में what is possible, circular में what is possible, linear में what is possible, right? So those 4 cases I hope are clear to you now. So we'll do one more question that is also on analyzing a graph. So this question came in 2021. Is anything clear what I just spoke? Or do you have any doubt? Because this is a little bit important. Yeah, सब लोग सो गए.
Yes, ma'am.
Okay, Rajat had anyway answered correctly. So, okay, so this is a question which came in 2021. So let us try to attempt this question. So a beam of light traveling horizontally consists of an unpolarized component with intensity I naught and a polarized component with intensity IP. ठीक है. So अब जो input beam है उसमें उसका कुछ component मतलब it is made up of 2 types of beams.
मैम
Input
फोटो
beam
थोड़ी
में
बड़ी कर दीजिए, दिख नहीं रहा क्लियरली, काफी छोटा हो रखा है.
ये एक्चुअली मैंने स्नैपशॉट दिया था ना. Wait, maybe I'll maximize my screen and then make it bigger. Can you see now? You can't. Okay. So यहाँ पे जो input beam है, it has a little, some component is unpolarized and some component is polarized. And now this input beam is passed through a polarizer. And polarizer का फिर से जो angle है उसको हमने रोटेट किया है पोलराइजर को, तो वो जो एंगल है उसके कॉरेस्पॉन्डिंग क्या इंटेंसिटी चेंज हो रहा है, जैसे पहले प्रीवियस क्वेश्चन में था वैसा ही एक ग्राफ हमें अब मिला है यहाँ पे. तो वी हैव टू फाइंड आउट दैट आउट ऑफ द 4 ऑप्शंस व्हिच स्टेटमेंट और स्टेटमेंट्स इज करेक्ट. सो इट ये MSQ में आया था बट इसमें एक्चुअली एक ही ऑप्शन करेक्ट है. सो बहुत आसान सवाल है, थोड़ा सा मतलब करके देखो.
मैम किस एग्जाम से है ये?
JAM 2021. मैं एक second थोड़ा minimize करना. I want to see if anybody has solved it. No, not yet. Okay, करूँ मैं solve? ठीक है,
मैम
देखते हैं
नहीं,
इसको.
एक मिनट और दो बस.
Can you please check?
Just a second. Okay. Dhruv, your answer is not correct. गलती की है. Rajat, your answer is correct. Sanchit, your answer is correct. Diptanshi, your answer is correct. Very good. Okay, Dhruv, please check. So let us try to solve this
Ma'am,
because
फिर
we do not have much time. Yes.
मैम फिर हम ऑप्शन नंबर ए के लिए चेक करें ना करें? मतलब आपने बता दिया एक ही करेक्ट है इसलिए नहीं कर रहे, लेकिन वैसे
नहीं, वो अभी पता चल जाएगा when I'll solve. Okay, वो that is an incorrect option. ठीक है. So what is given in the question? पहले तो मैं वही clear होना चाहिए. So the question is saying that we have a beam of light which consists of an unpolarized component with intensity I0 and a polarized component. So पहले तो ये लिख लेते हैं. So we have an unpolarized component which is I0 and we have a polarized component which is equal to IP. So up next, the question is saying that the plane of polarization is oriented at an angle theta with respect to the vertical. तो हमें बता दिया है कि जो भी polarized component है beam का, that is actually plane polarized. That is given in the question कि the plane of polarization is oriented at an angle theta with respect to the vertical. So if this is the vertical, my plane of polarization is this, making an angle theta. So now the question says that the figure shows the total intensity I total after the light passes through a polarizer. So ये जो complete light है जिसका कुछ component I0 है और कुछ component IP है, this whole light passes through a polarizer and we are rotating the pass axis of the polarizer and जो भी intensity मिल रहा है that we are plotting. ठीक है, that is what the question is saying. So now what I have here is I have a polarizer and this is the pass axis of the polarizer and I am rotating this pass axis by some angle alpha. ठीक है, this is what the question is saying और यहाँ पे मुझे कुछ I total मिल रहा है और I input है equal to I0 plus IP. So now a graph is given to me जहाँ पे मुझे I total दिया है यहाँ पे और यहाँ पे angle दिया है alpha by which I am rotating the polarizer, this angle alpha. I am rotating it in the XY plane. So now this graph is given, how is it given? So the graph is given something
Ma'am,
like this, yes.
the plane of polarization, which is given as theta, ma'am, that is the of polarized component, right?
Yes, only the polarized component. The unpolarized, so the input is actually this plus this. Right? This is the input which is falling onto the polarizer. This combined thing is falling. Okay. So now what will happen is, let us write कि क्या-क्या terms दिया है graph में. So इसका maxima दिया है मुझे. This value is given 25 watt per meter square and this value is given as 5 watt per meter square. And also let us write down these angles. So if we'll go to the graph, so I can say that this angle is actually kitna 125 and this angle is actually equal to 35. Okay, that is given to me in the graph कि maxima और minima कहाँ हो रहा है. So this is 35, this is 125 जो कि obvious है कि 90 degree का difference होना चाहिए इनके बीच में, right? This is 35 plus 90 is equal to 125, which makes sense कि मैं पोलराइजर को रोटेट कर रही हूँ तो एक पोजीशन पे अगर मैक्सिमा है तो उसके क्रॉस्ड पोजीशन यानी कि 90 डिग्री के डिफरेंस के बाद आई शुड गेट अ मिनिमम. ठीक है, बट अब क्या हो रहा है when this total light is falling onto the polarizer, so unpolarized component को क्या हो रहा है, this component I0 will simply become I0 by 2. ठीक है, and जो IP है, let me write it, that after polarizer this I0 will actually become I0 by 2 and जो IP है that will actually become IP cos square theta. और not even cos square theta, कुछ complicated angle आएगा. ठीक है, so let us say कि हम ये जो alpha है, let us make it a little bit easier. ये जो pass axis मैंने draw किया था, मतलब इतना सब करने की जरूरत नहीं है, but because we are analyzing the question, so अच्छे से ही करते हैं. So let us say कि हम pass axis starting में ना parallelly ले लेते हैं theta के, and now I am rotating it. So now when I am rotating it, तो every time इससे I am measuring. This is my first position and now I am rotating it. So this angle is now alpha. I keep on rotating it. So now this intensity will be this. Because ये जो orange polarization था, उसके respect में alpha amount से I am rotating the pass axis of my polarizer. So then Malus law if I will apply, it will become IP cos square alpha. ठीक है? अब I look at the graph. तो I total मेरे पास क्या होगा? Which is coming out. So this I total is equal to I0 by 2 plus this IP cos square alpha. ये मेरे पास total intensity है which I am getting after the polarizer. But
How
now
did you get the alpha angle?
that is what I said. See, this is my, I am free to choose that what is my starting point of the polarizer. कि polarizer का pass axis मैं कहाँ पे choose करती हूँ, starting कहाँ से करती हूँ, that is I am free to choose. So यहाँ पर I had
दिया हुआ था ये like it was started from vertical position in the question.
Yes मैम, अल्फा वर्टिकल से है ना.
ठीक है, तो अल्फा माइनस थीटा आ जाएगा फिर.
हाँ.
ठीक है, तो in that case we can take, then this is my theta with respect to the vertical. So I am starting like this, I am rotating it like this by alpha, and this angle is theta. So किसी भी एक position पे अगर मैं किसी और position पे देखूंगी, तो let us say this is the pass axis. So now this is angle alpha. So component के लिए alpha minus theta आ जाएगा. Is that okay? But it is immaterial to us right now. Is that okay now or not? I will get then alpha minus theta. You are getting confused. See, let me draw with other color. So this is my vertical. This is my y vertical. And now this green is the pass axis. So this angle is alpha and this angle is theta. So if I want to take the component, I will have to consider this angle, which is alpha minus theta. Is that okay?
Yes, ma'am. Okay.
Okay. But it is immaterial to us right now. You will see just in a moment that I'm doing it because I'm supposed to, so that you can handle any other question. But in this question, we don't need so much. Okay. So now what we have to look at the graph is, हमें सिर्फ दो चीजें notice करनी है graph से, कि what is the maximum intensity and what is the minimum intensity. That is all we need to notice. So we know कि maximum intensity हमें 25 दिया है, that at maximum value the intensity is equal to 25, and minimum जो intensity आ रहा है that is equal to 5. So if I look at my I total, अगर मैं इसको देखूं, so if I want to take I total का minimum, what is the minimum? आगे लिखना चाहिए था. Minimum of this. तो minimum of this का मतलब है कि whatever this term is, ये जो भी term है should be equal to 0. Then I should get a minimum. मतलब this alpha minus theta का जो भी है, this alpha minus theta should be actually equal to 90 degree. So that cosine of 90 degree is equal to 0, and the contribution of this term simply goes to 0. So that means the minimum value I can get is I0 by 2, because unpolarized light ke liye it's immaterial where however I place my polarizer axis, it doesn't matter. Now this is given equal to 5. So this tells me that I0 is simply equal to 10 watt per meter square. So I have found out one value. And now let us look at the maximum. So maximum I total का मतलब है that this alpha minus theta should be equal to 0. So that cosine of 0 is equal to 1. And the contribution is maximum value क्या हो सकता है? IP cos square alpha minus theta का maximum value क्या हो सकता है? IP हो सकता है, because cosine is going to vary from, because it's ये तो square function है. So 0 से 1 के बीच में it is going to vary. So I total का maximum value हो सकता है I0 by 2 plus IP. And this is true when alpha is equal to theta, which is obvious कि जो भी मेरा polarization, input polarization था, उसी के parallel अगर polarizer का axis है, then I will get maximum intensity. It is obvious. So then this number is given to be equal to 25. So then IP is equal to 25 minus I0 by 2. So 25 minus 5, which is equal to 20 watt per meter square. ठीक है. और अब जहां तक मात्रा ऑप्शन नंबर ए का, so option number A is saying that theta is equal to 125. but we have just now figured out that theta is actually equal to alpha. ठीक है, थीटा का वैल्यू अल्फा है, तभी हमें मैक्सिमम इंटेंसिटी मिल रहा है. ठीक है, अगर थीटा का वैल्यू अल्फा मतलब थीटा मैक्सिमम पे क्या वैल्यू है, मैक्सिमम पे 35 डिग्री वैल्यू है ना अल्फा का. तो हाउ डू आई फाइंड आउट द वैल्यू ऑफ थीटा? थीटा वही वैल्यू होगी ना जहां पर अल्फा क्या, अल्फा इज पैरेलल टू थीटा. if the pass axis of the polarizer is parallel to the polarization of the input beam, उनका जो orientation है both are same, only then I will get maximum intensity. So this tells me that theta is nothing but equal to alpha when the light is maximum. So therefore the theta is actually equal to 35 degree and not equal to 125. So we don't have to figure that out क्योंकि theta तो fixed है, theta तो input में fix है. We are not changing theta, we are only varying alpha. पर हमें थीटा का वैल्यू कैसे पता चल जाएगा? थीटा अल्फा का वो वैल्यू जिसके ऊपर मैक्सिमम इंटेंसिटी मिल रही है विल कॉरेस्पॉन्ड टू द वैल्यू ऑफ थीटा, बिकॉज देन दे विल बी पैरेलल टू ईच अदर. So then theta is equal to 35 degrees. So option A is not correct. So let us look at all the options. A is not correct. Theta is equal to 35. We have just proved. And IP is not equal to 5. IP हमने 20 निकाला है. I naught भी हमने 10 निकाला है. So the only option that is correct is option number D. So यहाँ पर कुछ भी नहीं हमें extra पता होना चाहिए था. हमें सिर्फ ये पता होना चाहिए था how a polarizer works. How do I make this graph, intensity versus the theta का ग्राफ क्या इंटरप्रेट कैसे करना है, सबसे इंपॉर्टेंट इनपुट क्या है, डिफरेंट तरह का. अब मैं इसमें ये क्वेश्चन अलग तरीके से भी बन सकता है, that rather than giving you a plain polarized input, I can give you a circularly polarized input and some unpolarized beam. Are you understanding? So multiple variations of this question can be formed. इसीलिए I spent time discussing the previous question so that we know that अगर हम एक polarizer के थ्रू किसी भी तरह का light pass करेंगे तो what kind of graph I can expect. ठीक है, so that's why I'm saying this is an important topic, Malus law, and it's very easy if you understand a few simple basic ideas of this कि मतलब what are we trying to do, Malus law apply कैसे करते हैं, मैलस लॉ किस बीम पे अप्लाई होगा, सिर्फ पोलराइज्ड लाइट पर मैलस लॉ हम लगाएंगे. अदरवाइज अगर अनपोलराइज्ड लाइट है वी विल सिंपली रिड्यूस द इंटेंसिटी टू हाफ. इट डजंट मैटर व्हाट इज द पास एक्सिस ऑफ द पोलराइजर फॉर एन अनपोलराइज्ड लाइट. कोई भी पास एक्सिस हम रख दें वी विल ऑलवेज गेट I naught by 2 इंटेंसिटी. ओके, सो ये सब चीजें अगर पता है तो वी कैन सॉल्व दिस क्वेश्चन. इट्स नॉट एट ऑल डिफिकल्ट. एंड see it came very recently also. So मतलब मेरा suggestion होगा कि by the time this course gets finished and by the time you have your exam in January, तो बीच में काफी महीने का 1-2 महीने तो मिलेंगे, 2-3 भी मिल सकते हैं. In fact, if we finish it by first or second week of October, and you will forget everything about this by the time exam comes. So if you are short of time and you cannot read the whole optics, at least do not leave polarization, interference, diffraction. ये topics तो बिल्कुल मत छोड़ना. Wave and phase velocity, basically waves and wave optics तो you have to be very good at, because these are extremely simple questions if you understand कि क्या basic क्या मतलब points हैं. So wherever you are making your notes, also make a sheet कि these are the mistakes that I'm going to do in the exam. So सबसे पहला mistake है I'll not look what is the input to my system. ये questions अभी easy चल रहे हैं because we are only dealing with a polarizer and an analyzer. In the next class we will also add a quarter wave plate, half wave plate, and we'll have to analyze कि output क्या आएगा. ठीक है, so just also keep on writing on a piece of paper that these are the mistakes I'm going to do in the exam. So first mistake is I'll not look at what is the input to my system. Is it polarized? Is it unpolarized? I will forget to reduce the intensity of the unpolarized light by half. This is what everybody does. Okay. And you should also be very clear that how am I writing in elliptically polarized light का expression क्या है, circularly polarized light को कैसे लिखते हैं, what is the property of a circularly polarized light, what do I mean by a plane polarized light. ठीक है, ये सब चीजें बहुत आसान है. So just try to revise them and do not lose marks on this topic. बहुत simple है ये. अब देखो 2 marks का question था, question number 33. It was an MSQ. So it was a 2-mark question, but it was not that difficult, right? So 9:05 हो गए. So ये topic यहाँ पे खत्म होता है, Malus law. So in the next class we will start with double refraction in birefringence. So what are birefringent materials? What is double refraction? How do we make a quarter wave plate? What is a half wave plate? And how do we basically change the state of the polarization by using these optical elements? So if I want to convert a plane polarized beam to a circularly polarized beam, or I want to convert a circularly polarized beam to an elliptically polarized beam, or any going to and fro between different polarizations, so uske liye we use components known as retarders. So retarders kya karte hain? They simply introduce an extra phase difference between the two components of the beam. तो अगर मैं एक plane polarized light लूँ जिसका कुछ x component and y component है, and imagine I'm passing, मान लो x and y 2 आदमी हैं, ठीक है, and they are walking एक साथ they are walking, ठीक है, but now I want to make sure that one person walks faster and one person walks slower. So let me say that I introduce some kind of a barrier in their path, कि एक इंसान जल्दी जल्दी चला गया, उसके पाथ में कोई बैरियर नहीं है, दूसरे का पाथ लेट अस से बहुत स्लिपरी है, तो वो बहुत धीरे धीरे चल के जा रहा है, एंड दे आर नाउ एट अ डिफरेंट डिस्टेंस. सो देयर इज अ लैग बिटवीन द टू. ओके, सो इसीलिए वी यूज अ रिटार्डर, इसलिए नाम है रिटार्डर, बिकॉज वी स्टॉप द वन component of the beam from moving with the same velocity as the second component. So basically one component will travel faster, the other component will travel slower, and due to that they will have a phase difference between them, and we can tune what is the phase difference we want, and by that we can convert a plane polarized light into a circularly polarized light or an elliptically polarized light and like that. So next class में आने से पहले I would suggest that you revise, I don't know which lecture was that, let me check, maybe 23 होगा. हाँ, तो 23 भी नहीं, इनफैक्ट 22 था, 22 एंड 23 दोनों थे, जहाँ पर हमने ये स्टडी किया था कि 2 प्लेन पोलराइज्ड लाइट से हाउ कैन वी मेक circularly elliptically polarized lights and like that. So revise this part so that it's easier for you. Jab next class mein we will be adding half wave plate and quarter wave plate and introducing an extra phase difference between the two components. तो क्या बनना चाहिए? It will be easier for you to understand the next class if the lecture 22-23 is clear to you. ठीक है? और ये पोलराइजर के भी क्वेश्चन आएंगे बाद में. इट विल बिकम ऑल खिचड़ी. विल हैव अ पोलराइजर आल्सो, अ क्वार्टर वेव प्लेट आल्सो, हाफ वेव प्लेट आल्सो, but it will be interesting also. It will be like solving a puzzle. So I think you'll like it. So I'll stop the class now because next topic is anyway time ho gaya hai, and the next topic is like we need to do it, give it some time. It's a long topic and it's important. इस पे क्वेश्चन आते हैं, बायरफ्रिंजेंस, डबल रिफ्रैक्शन. उसके बाद पोलराइजेशन के टॉपिक्स बहुत आसान है, सिर्फ एक ही टॉपिक करना है, ब्रूस्टर एंगल वाला एंड रिफ्लेक्शन वाला कुछ. उसके बाद वी कैन गो टू इंटरफेरेंस. सो आई विल स्टॉप द क्लास.
पोलैरीमीटर नहीं है ना अपने सिलेबस में?
पोलैरीमीटर नहीं है. ऑप्टिकल रोटेशन का एक टॉपिक है बट उसके ऊपर कोई क्वेश्चन आता नहीं है. तो ऑप्टिकल रोटेशन मैं देखूंगी, या तो बाद में करेंगे या फिर हम नहीं करेंगे क्योंकि इस पर कोई क्वेश्चन नहीं आता है. और पोलैरीमीटर तो है ही नहीं सिलेबस में. सिलेबस में इनफैक्ट मतलब डबल रिफ्रैक्शन और बायरफ्रिंजेंस भी मेंशन नहीं है, पर उस पर क्वेश्चन आते हैं. सो ये दैट तो हम विल डू. ठीक है, विल डू इन एंड इवन ब्रूस्टर पे भी क्वेश्चन आते हैं, दैट इज नॉट मेंशन इन द सिलेबस, बट ऑप्टिकल रोटेशन पे कुछ भी नहीं आता है। और जैसे नाइकॉल प्रिज्म हो गया, या फिर एक और होता है ना फ्रेनल रॉम्ब या समथिंग लाइक दैट, उस पे भी क्वेश्चंस नहीं आते हैं, ऑल्दो दे आर गिवन इन द बुक्स, सो वी डोंट हैव टू नेसेसरली रीड दैट, बट जो जिस टॉपिक्स पे आते हैं क्वेश्चंस वो तो थोड़ा अच्छे से वील डू। सो नेक्स्ट क्लास में वील डू बायरफ्रिंजेंस, सो ट्राई टू अटेंड द क्लास, बिकॉज बहुत सारे केसेस होंगे उसमें भी कि ये होता है तो ये होता है, ये होता है तो ये होता है, तो स्लाइटली थोड़ा सा याद, मतलब नॉट याद, रिवाइज करके आना कि लेक्चर 22-23 में क्या था, ठीक है। सो आई विल स्टॉप द क्लास नाउ। गुड नाइट।
थैंक यू मैम।
थैंक यू, बाय बाय, गुड नाइट।